I'm the director of development for a mobile solutions agency in Houston called Chai1, and we do iOS, Android, and Rails development. I also run NS Screencast. This offers weekly videos, small videos, about 10 to 20 minutes each week, and that's $9 per month, all on iOS development. So why is this topic important? Why is networking important? Pretty much every app I've ever written has to access data that's not on the device. And unless you're writing a flashlight app or a calculator, even a calculator usually needs to talk to the internet if they need to download things like exchange rates or whatever. So 99% of our apps are not self-contained. And doing it wrong ruins the user experience. Right? There's all sorts of things that can go wrong if we don't do this the right way. And I think too many apps do this wrong. So I'll show you a few examples. One of them is what I call the stuttery scroller. This is the type of application where you scroll a table view and expect it to be smooth like butter and scroll at 60 frames per second, but it doesn't because the developer is doing something like accessing a network on the main thread during the scroll event, maybe. This is an example I call the perpetual loader. So if you could imagine sort of a drill down, lots of table views, you tap on one, you go to the next, you tap on that, you go to the next, and each time it shows you a loading screen, every single time. So, that's sometimes unavoidable, but what is really frustrating is if you go to an item and it loads, and then you go back and go to the second item and it loads, and you go back again and go back to the first item, that data has already been downloaded once. Let's not download it again. I've seen apps like this where they present a loading screen before you can even do anything with the app, right? They present you a modal loading screen, and so they're loading all the content up front. And so there's got to be some balance between all these approaches. If you have something like an activity feed or Twitter, for instance, if I were to make a tweet, what is the very first thing I would do after making that tweet? I would scroll to see it in my timeline. And if my timeline is showing me cached data, then I'm not going to see the thing I just added, and that's not going to be so great. And I call that yesterday's news. Stuff that cached data may be for too long. So what we're going to cover today, some NSURL session basics. This is the new stuff that was introduced in iOS 7. We'll do some live demos, provided my laptop mouse works this time. I think it will. We'll talk about AF networking 2.0 and how that applies to the new networking stack. We'll talk about HTTP caching, some caching patterns, and time permitting, some API design tips. So let's get into it. So NSURL connection is what we've used up till now to do networking. This was introduced for Safari around the dawn of the millennium, and it was made public for developers to use in around 2003. To give you a frame of reference, this is the computer that was out at that time, the iMac G5. So you can see that this is a really old API. It served its time, but now it's time to put it to rest and get with something new. And one of the problems with NSURL connection is it had a global reference for settings, configuration, cache, authentication, things like that. And oftentimes, if you were to use a third-party library that needed to tweak those settings, like cookie storage or credential storage or whatever, those settings might conflict with your own. So this is now replaced by NSURL session. This is a family of classes, but it itself is also a class. So we'll talk a little bit about this class hierarchy. So NSURL session still uses some of the familiar classes like NSURL request. NSURL request is used to describe get, put, post, or delete, what URL and what parameters, also what headers. And NSURL session has a configurable container called NSURL session configuration. And this is what you would use to configure things like cache or cookie storage. It has much improved auth, so if you need to do something like NTLM or Kerberos or client certificates or whatever, NSURL session has a lot more capabilities there. And there are rich callbacks using blocks and delegates, so you can get sort of the fine-grained detail if you need to. So this is what it looks like. We have this outer container, this NSURL session. This sort of represents your interaction with one API. It may even be one interaction to a single endpoint. It's got a configuration object, like I said, with cache, cookies, credential storage, different protocols, things like that. It also has a delegate, which is optional, but can provide you information about what's going on with your NSURL session. And the real beauty of this design is that we can have two of these, and they can coexist, and they don't stomp on each other. The settings can be completely different. So these are the classes you'll typically interact with. We have NSURL session, which we've already talked about. We have NSURL session configuration. This is actually the first thing that you'll create because in order to get a session, you need the pass it a configuration. Once you have a session, you'll use that session to build a number of NSURL session tasks. And the NSURL session tasks represent your individual requests. And at the bottom in green is an NSURL session delegate. It's colored green because it's a protocol, not a real class. And we'll dig into that more in a second. So NSURL session, this is your interface for network calls against a server. The likely use case here is one NSURL session per API. You can do things like, for every request to this, using this session, I want you to use the same set of default headers, and things like that. NSURL session task, like I said, represents the individual requests that you're going to make against an API, and starts off with this base class at the top, which provides some default behavior of canceling, suspending, and resuming tasks. Now, all tasks, when they get created, start out in the suspended state. So in order to get a task to actually run and the network call to be made, you have to call resume on it. On the left side of this diagram, we have the NSURL session data task. This is the typical one that you're issuing a call in order to download some data, right? Like I want to get some JSON data or some XML data from an API. This is the kind of the typical workhorse for an HTTP request. A subclass of that doesn't really for a download, save that. Since it's an NS data pointer, you could serialize that to disk. And then the next time the app launches, you could resume that download. So this is the way you create a data task. You ask a session to give you one for a given URL. This is actually a convenience API where I can just give it a URL. This is going to do a GET request. If I wanted to do a put or a post or a delete, I would have to use the alternate method that I pass in the URL request itself. And I say easy callbacks here because this one gives me a block that will tell me when this request is finished, and it will give me three things: the data of the response, and I have to interpret this however the API is written. So if it's going to return to me HTML, then I can cast it as, or convert it to a string. If it's going to return JSON, then I can use NSJSON serialization and convert it to like a dictionary or an array. And if it came back in error, then we will get an error here. And the NSURL response, typically you'll cast that to an HTTP URL response so that you can get the status code. So NSURL session delegate provides more advanced callbacks, not via blocks, but by delegate methods, that you can use to get things like connection failure, auth challenges, download progress for downloading data, and completion, just like we saw. It's actually a protocol family, which is kind of an interesting thing. I don't think I'm aware of any other place in the framework where they use this pattern. But our NSURL session has a delegate property, and that delegate property's type is NSURL session delegate. But these are all sub-protocols of this protocol, so you're free to substitute any one of these. If your class needs to know about download delegate information, then it will conform to this protocol and set itself up as the delegate of the session. So it just depends on which type of callbacks you want. And they're inclusive. So this one at the bottom includes all the ones above it. And you should look at the headers to see what the methods are that each one of these provide for you. So let's talk a little bit about a simple example of requesting images. So have you ever seen code like this? Just take a look at it for 1 minute. We have an image URL. Then we're trying to get NS data, image data, equals NS data, data with contents of URL. Does this look familiar? UI image with data, image data. Have you all seen code like this? Have you all written code like this? Okay, this is wrong. This is very wrong. Why is it wrong? It's a blocking call. I think both of these lines are suspect here. Especially the first one, right? It's going to stop, make a network call, and my phone right now is using the slowest possible internet connection it supports. So this would actually take a long time to download this image on my phone. And meanwhile, I can't process any user interface events or scrolls, touches, anything like that. The second call here, once we do have the data, it may not be in the internal representation that the UI image wants. So there may be some conversion going on there. So I would prefer to do both of those in the background. But wait, you'll say, we have GCD. I can just wrap this in a dispatch async and do it in the background, and then everything's good. But I still think that these things, particularly this method, data with contents of URL, should probably be just deprecated and removed from the framework altogether, because there's no way to present progress of this. There's no way to cancel it. There's no way to see what error happened. If I remember correctly, this will just return nil for the image data if something goes wrong. So it's just a poor way to, I mean, it's an easy way to make a network call, but it's just not for use in a shipping app. And in case you were wondering what that image was that we were downloading, here's a headline from a Canadian paper: "Sister hits moose on way to visit sister who hit moose." I haven't spent a lot of time in Canada, but apparently they have a moose problem. Okay, so let's do a demo where we download an image using NSURL session download task. So what we're going to do here is jump over to Xcode. I have an image URL for a less funny image, and we're starting from a blank slate. You can see here at the top I have property for NSURL session, and in order to create one of those, I need to create an NSURL session configuration, and I'll call that config, NSURL session configuration, and I can create my own, or I can just use the default. And the default will have all the settings that NSURL connection has today, default cache, and things like that. I might also choose the other sort of factory method that we have here is ephemeral session configuration. And that sort of means private browsing. So if you're doing something sensitive and you don't want anything cached, you can use an ephemeral session configuration and it won't store anything. No cookies, things like that. Okay, so I'm going to use the default. Now that I have the configuration object, I can say self.session equals NSURL session, session with configuration. I'm going to pass in config. Now I want to create my download task. So I'm going to say self.download task equals, again, I'm going to ask the session for a download task. So I'm going to say download task with request. And there's all these overloads here. I can pass in the resume data. So you see how we would resume a request in this way. So the download task itself, when it's canceled, is thrown away, and we would just create a new one by producing the resume data there, or passing in the resume data there. And I'm going to use this one here, where I take the URL and the completion handler. This is the same one we saw on the slides. So now I'm going to pass in that image URL that we already have above, and take a look at this response. Okay, so we have the location. In this case, it's a download task. This is slightly different from the other one that I showed you, which was a data task. The difference is that it gives me the location of the downloaded file. The data task gives me an NS data pointer. The downloaded file is in a temp folder, and it will be deleted very soon. In fact, probably after this block exits. So if you need it to stick around, you have to copy it into the documents folder. So I don't really need it to stick around. All I want to do is pull out the NS data for that image. But I'm getting ahead of myself here because this request may have actually failed. In fact, if this network doesn't hold up, it will fail, and we'll get to check that code too. So the first thing I need to do is check to see if we got an error. Now, error in this case means the actual request I couldn't get a response from the server. It means the request failed. AF Networking 1.0 had a completion callback with success and failure callbacks. The success will get called for any 200 level response, and the failure callback will get called for any non-200 level response. So failure in AF Networking 1.0's eyes was a non-successful HTTP status code. In this case, this means like there was a network error and I couldn't even reach the device or the server. So in this case, I'm just going to log it because that's what we do with errors, right? I'm going to log the error and continue. I probably want to do something like a network activity right before I do this. And right here where I'm done with the response, I'm going to say dispatch async. Remember, we're on a background thread. Well, I guess I didn't tell you that yet, but we're on a background thread. So in order to talk to the UI, to update any kind of UI code, we need to make sure that we dispatch async and get back on the main queue. So here, I'm going to dispatch get main queue, and then I'm going to set the network activity indicator back to no. Okay, so at this point, we're just logging the error. In the else block, we know we've actually received a real request from this API or from the server. So I do want to check the status code, though, because in this block, I could have gotten a 404 or a 500 from the server. So to do that, I need to cast this to an HTTP URL response. I'll call it HTTP response, and I will just cast that. And then I can check the HTTP response status code and make sure that that's 200. And if so, I'm going to do something. If not, I'm going to log the error, because that's what we do. I'm going to say received HTTP %d and status code. Okay, so this is our success block. And inside the success block, I want to grab the data for this file and then associate it with my image view. And I didn't really show you what this app looks like, so let me just show you a storyboard so you can better visualize what's going on here. In our storyboard, I have a full screen image view, and I have at the bottom a toolbar with a download image button. So we're writing the code for this action when I tap on this thing here. And I also have a progress indicator, which will lead you to the second part of this demo. I'm not going to worry about progress for now. Okay, so back to our view controller. I want to get an NS data, and I'm going to say image data. That's going to be NS data, data with contents of URL, because that's what they gave me right here. I'll say location. And this is fine to do right here because we're on a background thread, right? Again, I'm going to say UI image, image equals UI image, image with data. And I'll pass in my image data. Okay, now that I have an image, now I can dispatch async again, dispatch get main queue, and now I'm free to associate this with my image view's image property. With me so far? Okay. Is this going to work? What did I forget? It's subtle, I know. I forgot to resume my data task, which is not at all intuitive because it's not paused. I mean, it starts in the suspended state. You have to remember to resume your tasks, otherwise they won't be sent. Okay. So I'm going to build. We're all good. Let's go ahead and run it. Okay, click download image. See the network indicator at the top, and the image comes in. All right. Pretty awesome, but not really that awesome. Okay, I would like to show progress of this image being downloaded. And to do that, I have to conform to that delegate I told you about, NSURL session download delegate. If we take a look at NSURL session download delegate, we have methods like download task did write data, total bytes written, total bytes expected to write. So with some simple division, I can figure out what the percentage is and associate that with my progress view. So I've already implemented these stubs. In fact, I don't need this bottom one. This talks about resuming. But I do need the first two. So I'm just going to convert one to the other. So the first problem is that our session, we need to set the delegate on our session to call our view controller. And that's a read-only property on session. I can't set the delegate like this. That's because you probably have, or you might have requests in flight, and if the delegate gets changed while you have requests going, that just is kind of unexpected behavior. So you have to create the session with the delegate. So right here for this session with configuration call, you can pass in a delegate. I'm going to pass in self and a delegate queue. This is the queue that those methods are going to be called on. So I could say call it on the main queue if I want to, Or I could just pass in nil, and it will use its own background queue to call those methods. If I've done that, now my class is going to receive methods about download tasks that, or any task really, that executes, with the exception of ones that already have a completion handler defined like this. If I've defined a completion handler, then it won't call my delegate methods for this request. So what I have to do is change this to just use the variant Xcode's trying to be helpful, and it's not at all. All right. Just use the variant that takes the URL or the URL request. And we need to take this completion handler code and sort of tuck it into the appropriate methods of our delegate. So the first thing we need to know is when so it tells us we finished downloading to URL. And so if we've done that, then that means there's no error. So I'm going to just cut and paste this code into here. We have a few things to clean up. One, we were not given the response, but we can get that from our download task. So everything is good there. So we've got our happy path working okay. But our error case doesn't work. So what we need to do is override another method from NSURL session delegate. URL session did become invalid with error. And here was where we have the error pointer, so I'm just going to log the error here. Now, I have a little bit of cleanup I could write. I need to make sure that I can set my network activity indicator to not be spinning in both of these cases. Okay, and then now it's time to do, so I've done everything that I need to do there. I want to leave in my resume call, and now it's time to calculate progress. So we can do that by calculating a simple CG float, %. Remember, we have to cast one of these values, total bytes written, divided by total bytes expected to write. If we don't cast one of the values, we're going to get integer division, and it's not going to give us at all what we want. So now that we have a valid floating point number, I'm going to dispatch async, dispatch get main queue, and I'm going to associate this with my progress view %. And I think I want to make sure it's not hidden, because I may have hidden it at some point. Okay. And then I probably want to hide it when my request is done. Okay. Let's run it and see where we are. I click download image, and now you can see the progress going through. Okay, so it's a little strange to me, actually, that the callbacks, the delegate callbacks, those methods, don't quite one-to-one map with the callback that we got when we used the block one. But it does provide you more advanced sort of information that we can use, like the progress. Another thing that's interesting about the callbacks, for a data task callback, the NSURL session data task delegate, it will tell you when a data task becomes a download task. And that could happen is if you make an API call, and then the API redirects you to a file to download. So you will have to handle that. Okay, back to the slides. Okay, so NSURL session data task, like I said, is kind of the workhorse of an HTTP interaction. Get, put, post, and delete for any kind of data. And similar callback, right? If an error is present, then the request failed, and you can handle the completion callback through the block or through the delegate callbacks. So what constitutes an error? Like I said earlier, the connection failed. It timed out. You had a bad host or a bad URL, too many redirects. There's about 50 errors in the URL loading system error codes documentation of all the things that could potentially go wrong when talking to a server. So let's go through another demo here. This time we're going to be searching the iTunes store. So let me go to Finder here, and I'll go open up this project. So this project, I'll open up the storyboard so you can see what we have. I have a navigation controller as my root. Scroll over, I've got a table view controller with a search bar at the top and my own custom cell. And the idea is I'm going to type a search term. We're going to search the iTunes store to get some results and render them in the table. So some of this code is already written. In fact, all of it except for the API call. So what we do here, when I call search for term, I start a network loader activity indicator. I clear any current results that are in my table view. I need to encode my search because it's going to go into a query string. So if I type something like Breaking Bad, it will be breaking %20 bad. Then I create my URL string. This is how I'm going to talk to the iTunes API. This is the affiliate search API. I'm going to search the US store for the given term. I'm going to create an NSURL out of that and then make an NSURL request for that URL. Okay, so now it's time to perform the API call. So I'm going to use a little snippet there to make that faster. And now it's time to parse this data. And it's kind of the same thing I already told you. We check the error first. If there's an error, that means the network request failed. Then we check the HTTP status code. And if it's 200, then we can treat it as successful. So I'm just going to cheat and paste in that code. In fact, in this code, I was not checking the error. So I have one level additionally that I would check in a shipping application to make sure that there was no error before proceeding with this. And then I call this handle search results data, which binds the JSON data to the table. Oh, what did I forget? Resume. I think I forget this about every other time I do it. So let's see. So I have my task, and I call resume on it. Okay. So this is going to search the US store for anything in the iTunes store. Movies, TV shows, music, whatever. What's your favorite American TV show? Breaking Bad. All right, awesome. So I search for Breaking Bad, and this is going to return to me all kinds of items, probably seasons of Breaking Bad, so I'm going to have multiple of the same exact data, but it will be episodes in a different season or whatever. And the network is quite slow. Wait for it. Hopefully, I wrote the error handling code right, and this will time out eventually, and then we'll see it time out. Looks like my network is dead. Oh, there it goes. Okay. So we have some records in here. And I didn't deal with the images yet, but that will come next. So when dealing with images, this is kind of a tricky situation, right? I have a cell-for-row-at-index path method that's called 1, 2, 3, 4 times. And then if I scroll off, this cell goes into a reuse queue and is put up right here at the bottom. So if I had an image in here, when it gets reused down here, I need to clear out the image. And if I'm requesting an image for one of these rows and they go off screen, I need to make sure and cancel that. So let's go ahead and handle all those cases right now. So in the cell-for-row-at-index path method, I'm going to clear the previous one. So I'm going to say cell.artworkImageView.image equals nil. And I decided to keep track of the task on the cell itself. So my cell has an image task, image download task. So I'm going to say cancel. And one of the nice things about Objective-C is nil is a no-op, so I don't really need to do any nil checking here. I can just say, well, if there is one, cancel. So now I'm going to grab the image URL. Not all of the results you're going to get from this API are going to have this URL. So I check to make sure we do have one. And then I want to create my, I'm going to say self.session data task with URL, image URL, and then, actually I have this already in here. So here I say data task with URL. I have my completion handler. Again, I'm ignoring the error case, which I should not do, but this makes the code a little bit cleaner. I check the status code. I get the image from data, and then I associate it with my image. Now the image view is smart enough to know that when you change the image that it needs to set needs display, so I don't need to do anything else there. Okay, so if I search for Breaking Bad again, hopefully it will be slightly faster this time. Oh, no, I didn't forget because it was part of my snippet. My prior self was smarter than my current self. Okay. While this is happening, I'm going to open up Charles. Anybody here use Charles already? Awesome. Charles, I use this all the time. And in Charles, I can go over to the sequence thing here, and I'm going to type MZ. I believe that is the start of the URL for the images. Looks like it's downloading now. Oh, our error code worked. So, yes. It's actually the first time I've ever seen it. Let's try it one more time. And if it doesn't work again, you're just going to have to trust me. There it goes. Okay. And I was wrong on those image URLs. So let me clear this out real quick so we get everything. And I'm going to scroll. Oh, you know what? I think I was right. But did you notice how fast those URLs came in? Like the JSON response took 15 years, but the images came in instantaneously. That's because I searched for Breaking Bad already because it's one of my favorite shows. Let's pick a show that I haven't searched for before. Any guesses? How about The Tudors? Anybody watch The Tudors? It's a good movie about Henry VIII. Okay, so this time you saw those come in. They trickled in. And you can see those requests here. So these are all the same image. So I didn't do any checking to see if all the cells that are on the page right now, if there's a request in flight for the same exact image. I didn't handle that. But if I scroll a little bit, notice how no new requests are made for that exact same image. That's because those are already cached. So I didn't write any caching code yet, but caching is being handled for me by NSURL cache. Okay, so let's move back over to the slides. Okay, so that's a pretty brief overview of all of the stuff in NSURL session, all the stuff in iOS 7. Now, NSURL connection's still around because some of us need to support iOS 6. Some of you told me you had to support iOS 4, which is kind of heartbreaking. But eventually, everybody will be on iOS 7, and you'll be able to switch fully to this new API. It supports all kinds of new things that go hand in hand with some of the new features in iOS 7, like background fetching and things like multitasking and things like that. So it's beneficial to, even if you have to support iOS 6 and 7, to support both sets of APIs. Okay, let's talk about AF Networking 2.0. How many of you here use AF Networking? Okay, that's what I figured. A lot of people use AF Networking. And I'm a huge fan of AF Networking. I've used it in every single app, pretty much every single app I've developed since I stopped using ASI HTTP request. Anybody still use ASI? A couple people? Yeah, that is some really, really old code, and you should probably move on to something better. So AF Networking 1.0 was a really cool design based around NS operations. I'll talk a little bit more about the design in a second. To install it, you gem install CocoaPods. You create a pod file. In this case, I'm saying I want an iOS app targeting 7.0, and I want AF Networking 2.0 in my app. And then I pod install, and it will create a workspace for me, download the code, and link it for me. So this is AF Networking 1.0's design. Everything was sort of based on NS operation. Then we had an AF URL connection operation. And for 99% of the time, we're dealing with HTTP stuff. You notice I had to cast that NS URL response, the NS HTTP URL response, which is really annoying, which is why AF Networking has an HTTP request operation, which does this casting for you. But this is all based around NS URL request and NS URL connection, which are now deprecated. So in the same line that in the same vein that NSURL connection is deprecated but still around for you to support these other apps, AF Networking 1.0's design is still there for you to use, but there's a new design. The new design is based around NSURL session, unsurprisingly. There is no real base class here, but NSObject. And you have an AF/URL session manager. This basically you give it a session configuration, and it creates and maintains your session for you. And it can do some simple things like gets, puts, posts, and deletes, which make it a little bit less code than what I showed you earlier. Like I said, it also does the auto conversion of NS HTTP URL response for you. And those take advantage of the same players here, NS URL session, configuration, the task. I think one of the key differentiators, one of the cool design pieces that AF Networking 2.0 provides is request and response serializers. So instead of having an AF JSON request operation and an AF XML request operation, an AF image request operation, instead you just have the normal tasks that we would always use, but we can tell our AF URL session manager what our response serializer is, and I can give it any number of serializers, including a JSON serializer. So the usage is like this. Create a URL, create a session configuration, then I create a session manager, and I give it that configuration. So the only difference here is I'm not creating the NS URL session directly. Then on my manager, I set a response serializer to AF JSON request serializer, or sorry, response serializer. There is also a request serializer. So if you want to post JSON content to your API, then you would use the AF JSON request serializer, and it will serialize all of your parameters to JSON before sending. Then I call manager get with the URL, parameters, and a completion. The completion in this case gives me my data task that it just used to make this request, and a response object. This response object is already JSON. How does it know? Well, I told it. And we can handle the success case there. It also provides the failure block. In the failure block, we're also given the task that just failed and the error. One thing it doesn't give you, though, is the response object. This is something that I don't really like. I issued a pull request to add the NS data of the raw response body. It got rejected. I think Matt Thompson, the curator of this project, sees a different vision for these calls. They're for the simplistic cases where you don't need something like the response body in the failure case. That doesn't mean you can't use AF networking. In fact, I'm still using AF networking, but there are more times when I lean more on NS URL session and less on AF networking to do these things. One really nice thing, though, is the response serializer is now the place where you can get an encoded URL request easily. So if you want to use AF networking to generate your requests and do your parameter encoding, and so encode like your post body as JSON, for instance, that's really easy to do just by using the response serializer, or request serializer. Okay. Another interesting thing about this particular format is that resume is called for you, so you don't have to do that. However, this method does return the task so that you can cancel it if you want to. So if you're requesting XML, then you're going to use AF XML response serializer. If you're requesting a plist, AF property list serializer. Any kind of custom data format like message pack or something like that, well, you can write your own. It's a really easy protocol to conform to. If you're requesting images, you can use the AF image response serializer. It'll convert the NS data to an image for you. But you can also use the handy UI image view category, set image with URL, and it will asynchronously download that image and update the image view for you. This would have significantly cleaned up the code I just showed you for the cell images. So let's take a look real quick at the app.NET client. This uses AF networking. So let's take a look here. We have right here an API client. Now the API client, again, it's the same pattern it always was, but there's no more base class that inherits from AF HTTP client. Instead, you inherit from AF HTTP session manager. So there's some moving around of methods. Like before, AF-HTTP client was the one that generated URL requests for you. AF-HTTP Session Manager doesn't anymore. That responsibility was extracted into the serializer, the request serializer. There is a default request serializer. So this code is actually really easy to read. Again, we are initializing this app.NET API client with a base URL so that all requests that are generated from this client are going to get paths relative to that URL. And here we're setting a security policy. I'm going to touch more on this in a bit. But this is one of the reasons why you would use a common sort of shared client approach that can manage your NSURL session for you. We have a common security policy here. If we had things like auth tokens or other headers or something that we needed to add, we would do that here as well. So if we take a look at our view controller is asking the post object to get it a global timeline posts with block. So they're speaking in terms of the domain here. We're speaking of timeline posts, and then I get back an array of posts or an error. If there was not an error, then I hang on to the post and I reload the table. So let's take a look. We'll dive into this method here. This is using that shared client and getting a relative path with no parameters. And then it's casting, the result was encoded as JSON because that's the default. And we got that back already parsed because that's the response serializer. Then we do our parsing, convert the JSON data into post objects, and we call our callback block, which is our view controller. And I got to quit the simulator from the previous example. And providing the network is working again, we'll see the we see the timeline from app.NET, and this is a live timeline. And just using the same thing, the set image with URL for each one of these rows. And it's just really pretty seamless. So a couple of things I wanted to call out. One of them is you saw the network activity indicator, but we didn't see any network activity indicator code. So if we go back to the view controller, there is a UI indicator view, which it's casting the left bar button item of our nav controller to that view type. And then it's using this method here, set animating with state of task. So what this method does, it's provided by a category method that provided with AF networking. It will do KVO, key value observing, on the state property of that task. And anytime it's suspended, it will pause the network activity indicator. And when it's running, it will start it. I thought that was pretty elegant. Here's another category method, show alert view for task with error on completion. It's a little kind of a mouthful there, but that can also be handy to avoid your 4 brackets, UI alert view, all that stuff. Okay, so there's some goodies that we'll talk about here. One of them was that security policy I already talked about, policy with pinning mode, AF SSL pinning mode public key. So who in here is using SSL pinning already? 1 hand, 2 hands? Okay. SSL pinning is almost like a for-free security feature in your application. So with Charles, I can self-sign a certificate for anybody's API. The app can trust that certificate. And when it makes a call to apple.com, but Charles is my proxy, Charles gives back the SSL cert so that I can talk to apple.com encrypted, and Charles will decrypt it for me, and I can tweak the response and all that stuff. That's a huge security risk for your application, and it's super easy to do. I'm not a security person by any means, but I was able to do it just by poking around in Charles. What you can't fake, though, is if the client is checking the certificate of the server and making sure it's the certificate that they're expecting, not my self-signed one. The problem with certificates, though, is they expire. So if you put your certificate in the app, and you're checking the certificate against the certificate the server is returning, then you've got to ship a new app before that certificate expires. But it's kind of a neat trick that every certificate has a public key, and those public keys probably don't change. In fact, they shouldn't change. So you can pin to the public key of a certificate, and you won't need to ship a new version of the certificate when you renew it. So all the hard work's been done for you. All you have to do is set that line of code, and it will check the certificate. You have to drag the certificate into your project, and I think you have to name it a specific thing, like .cer or something like that. But that's it. We talked about this one already, the UI activity indicator view, set animating with state of task. That's pretty handy. So let's talk a little bit more about HTTP. This is sort of a cheat sheet I like to tell people. We don't use 100 level codes. 200 level codes means everything's good. 300 means it's over there, like any 300 level task or response code. A 400 level response means you messed up. And 500 level response means the server messed up. So it's a good sort of guide for what these mean. So let's talk about HTTP caching. I think this is probably the biggest opportunity for applications to feel more responsive if they take advantage of this stuff. Unfortunately, too few apps take advantage of this stuff. I have we used to have a time card app. It was a really horrible app for a time card solution. The web-based stuff was pretty nice, but their app was terrible. And oftentimes when I'd forget to fill out my time card, I'm walking to my car. I'm like, oh, I'm going to pull out the app. And then it's like downloading your client list. This is like current and past clients. It's a huge list. And their API is slow, so it takes like 10 seconds. So I'm like, okay, this client, 4 hours. And I go back to the thing, add new time again, downloading client list again. The entire client list, every time. So if I have to record like 3 different time entries, I got to download the thing 3 times. So I used that once and then never used it again. And then we switched time card providers. So, okay, so HTTP caching could have been used there. Here's an example of that. I make a request for some resource on the internet, and it returns back a response that looks kind of something like this. I get a 200 OK. It's some JSON content. It's 37 kilobytes. It's got an E tag, cache control header, and a date. So an E tag is kind of like a thumbprint. The cache control tells us how long the client can cache it, in this case 60 seconds. And the date is when this resource was modified. So on the client, we can save this E tag. And then the next time I request the exact same thing, I can say, if none match, and pass in the E tag. This is kind of like a hash of the contents from before that the server generated. So the client doesn't have to have any smarts here, just passes the same value. And the server can say, nope, that didn't change. And we can avoid sending down that 37K of data again. So all the work is on the server. The client just has to save the response and save the E tag. So this is good for things that don't change on a date basis. You might also use modified date for things that do change easily on a date basis. So in the same sort of form that we did the E tag, you can pass if modified since and pass the date you got last time. And again, the server can return a 304 not modified. So this is still a network call, but this is minuscule. It's tiny, and on a fast connection, it's almost imperceptible. On the server, it's a little bit more complicated. How many people here are server people? Only a few. Okay. Don't worry about this too much, but this is what I would do in Rails in a server. I work with music, so say I'm finding a band by ID. I'm going to get the band out of the database, and I use this nice Rails helper, which generates my E tag and last modified dates based on the resource I just pulled out, and it will halt the request right here with a 304 not modified if the request matches these new generated values. And I have to say public true, which will become important in a minute. I'm also setting the cache control header in this way, keep this data around for 10 minutes. So in the case we got a 304, I'm still executing this top line of code here, which is a database query. And if you have a slow database, this could add to the delay that we're going to get that 304. So the point here is the server is still probably doing a database query, but it doesn't render any template, and we don't spend any time rendering JSON or sending that to the client. So we save on bandwidth. So cache control is nice because you can tell the client, don't call me again for 10 minutes. And that's all I would have asked for that time card app. Just cache this data for 10 minutes. I mean, it's not like we change clients every 10 minutes. They could have cached it for like a day. but I would have been in and out in 10 minutes, and that would have been fine. So that's fine, but if you have a really popular app, cache control does have some limitations. So here, my phone is going to make a request for some data on the server, and it sends back and says I have a cache control header of 600, which is 10 minutes. Right? So the phone is fine. For the next 10 minutes, that phone's not going to make another request for the same resource. But we have all these other thousands of phones in the field, and they're all doing the same thing, and they're getting the same data. Right? So the server's a workhorse. He's doing his job, and he's sending the exact same response to all kinds of clients. So this helps with one chatty client, but it doesn't help with all of your chatty clients. So this is where you might introduce a Varnish or a Squid as a reverse proxy cache. These are drop-in appliances that you can set in front of your API. And your app sends a request. It hits this reverse proxy cache first, and it understands the cache control headers. This is why public is important. Don't put public on things that aren't publicly cacheable. But it will cache that at this tier. And so that means this guy also gets the same thing. He will stop sending requests for the next 10 minutes. But these guys also make a request and get an immediate response from this caching tier. These things are lightning fast. They're way faster than hitting like a Rails server and rendering a template or hitting the database. So cache control is nice. The client doesn't wait for a response from the server. It already knows that the content is fresh. If I'm within that 10-minute period, I don't need to make a request. We don't need to show a loading spinner. I can show the content right away. The server doesn't spend any resources because we didn't make the request. But that means that we could have up to 10 minutes of stale data. So if this is a Twitter app, that's totally unacceptable. So you have to reason about your data. So the pros and cons of eTag, if modified since headers. Server skips a rendering, saves on bandwidth. It appears instantaneous. Server's still doing a database query though. And on a slow connection like I have right now, it would take me a few seconds to get a 304, so it would still feel like a network request. So the point is to reason about your data. This is a list of US states or whatever. I don't expect that to change anytime soon unless we decide to make Puerto Rico a state. If it's a user's profile, that also doesn't change very often. I haven't changed my Twitter profile in probably 2-3 years. Customer's order, that's kind of private, I think. We probably shouldn't cache that publicly. An activity timeline, these things by nature change all the time, so caching in this sense is probably not the greatest idea. But there's a set of data that doesn't change. By nature, it doesn't change, like yesterday's weather, yesterday's stats. That data will never change. So we can cache the hell out of that. We can cache it for 10 years. And the way caches are built, they have a size and a limit, so we can just cache everything. And once you reach the limit of your cache, it just evicts the oldest thing you haven't requested before. So NSURL cache works like that. So the point I'm trying to make is a lot of times you have to make a choice between user experience and fresh data. If you want always fresh data, then the user's going to have to wait a lot to make every network request. If we want the best user experience, we might be rendering stale data. So I think there's a balance here, and you just have to make sure that you look at your data. So the good news here is if you're just doing the client side, all the work's been done for you. You just have to leverage NSURL cache and use a session configuration that has those caching settings. The default session configuration has good enough caching settings for most uses. You saw in effect already for the Breaking Bad photos. You can use the ephemeral configuration to disable caching altogether. You can also customize it. I found that the built-in settings for NSURL cache are really kind of conservative, and I'd like to be much more liberal with the amount of data that I want my app to cache. So in this case, 10 megabytes of memory capacity, 50 megabytes of disk capacity, and then in order to use this, you just set it on your session configuration. I think it's really important because this stuff is invisible to us. It's oftentimes easy to think it's working and it's not working. So sometimes I will open up this database and just take a look. And if you look at it, it will show you all the data. Shows you the request API, when it happened, there's a hash value. So that's the CF URL cache response. And there's also the blob data, which you can use in NSUTF-8 and code that to get the actual response body. So if you really want to know what's being cached, you can look in here. So I want to talk real quick about a pattern. I'm sort of running out of time, but I think this pattern deserves sort of a look. Say I make a request to some coordinator object, it doesn't matter what it is, service object or manager or I don't know, to get some data. And he starts a request and immediately returns cached data. So to the user, I see the network activity indicator at the top, but I'm already looking at data. I'm looking at the data we already had. Then an HTTP GET goes against the API. It takes a second. Then it comes back with a 200 OK. We parse the response. Cache is updated. And then we update the view controller again with the new data. So this is not something you get for free. This is something you would have to write a considerable amount of code for. I think there's patterns that we could probably adopt to make this stuff easier. One thing that might feel a little bit weird is our view controller got 2 callbacks for content. Right? You may not be expecting that. But I think this is an interesting pattern. One place we use this, for a radio app, you have a list of user stations, right? What stations they've saved. And the stations can change, right? If I go to the web and I add a station, I want that station to be immediately available on the phone. So I can't just cache these for 10 minutes. That's unacceptable. But I don't want there to be, as soon as the app loads, I don't want to be their empty list and then full list, right? Even on a fast connection, it's going to be empty list, flicker to full list. I'd much rather have some cache data. In our case, we save this to a plist. And I render it from the plist first. So that way you have data immediately. And then when the actual response comes in with the new data, I insert that row at the top, animated. So I will speed right through these design tips because this is the last session of the day and you guys are probably really tired. Don't expose your internal model. You want to decouple this so you're free to change your API, or rather change your internal model without having to change your API. And you don't want to break existing clients. So version your API. If you're not using some sort of analytics platform, then from the get-go, start sending things like this. This is nothing spammy or a violation of users' privacy. This is so that you can do your job better, right? So that you can know what devices are out in the field, what versions of the OS and the app. Have a way to notify your clients to upgrade. So if they're using a really old version of the API, you might want to build in some sort of messaging thing so you can say, hey, there's a new app in the store. Page large data sets. Some data sets are unbounded lists, like your Twitter feed. Build in HTTP caching support from day one. Like I said, your job is really easy. Take care when caching user-specific data, because you don't want to serve, somebody's private information to somebody else on accident because you used a public cache. Turn on gzip compression. This is like free candy. There's almost no reason you wouldn't turn this on these days. And measure your API response times so you know if your app is getting slower over time. So thank you for your time. Because I have time to take 1 or 2 questions. Yes.
Do you have any suggestions on patching existing data? This is related to caching, I guess, in some way. But if I have a large data set and something gets modified, any suggestions on how to handle that?
So you have a large data set and you want to cache only parts of it? So you don't have to download the entire thing if one little thing? Yeah, I think you have to split it up so you have multiple requests.
Yeah, hi Ben. First of all, I would like to thank you for such a wonderful information. And actually, I just have one small question. Let's say I have some request is going on for logging, or I'm downloading some data. Okay, meanwhile, the user press the home button on the iPhone. Okay, what will be the best practices to handle that situation?
I prefer to not spend any resources whatsoever if the user is not on that phone, but like on that particular screen. Like, for instance, if I go to a screen and I'm downloading the user station list and then I back out again, I cancel that request because I don't want to spend any time on it.
Okay.
If they hit the home button, though, they may just be looking up something else while this thing downloads. Like, I may have refreshed Instagram and then moved over to another app and hoping that when I come back it's already refreshed. So I think that there's probably a case for just letting the OS handle it give the backgrounding API some time to finish the request.
Okay.
But just make sure that you handle the cancellation portion of those background tasks.
Okay. Thank you.
Yep.
Thank you.
Hi Ben, I am using iOS 6.0 and I have been connecting to SOAP-based web services.
I'm sorry.
So it's a XML-based parsing. So unfortunately I didn't find any of the APIs for that, for XML parsing. So would you suggest any third-party tool, like we have some Visual to OBJC and someone else?
So I've only done this once, and it was like probably 3.5 years ago. I've been a little bit more fortunate that I haven't had to deal with SOAP on iOS. But is there NSXML parser? Is that available on iOS, or is it only Mac? It's iOS? Yeah. So, and then back then we used Kiss XML because I don't think NSXML parser was available on iOS then. But for dealing with SOAP web services, I'm not aware of any good libraries for that.
Okay. Thanks, Ben.
Thanks. Oh, I forgot to mention the slides from this session are at speakerdeck.com/subdigital, and the code that I presented here and in the previous presentations are on GitHub there. Okay. Thank you.
Thank you, Ben. With the end of this talk, we close the 4th edition of Mobile Developer Summit. Thank you, everybody, for